Myself Professor Satish Patil, Assistant Professor in Mechanical Engineering Department of MIT School of Engineering in MIT Art, Design and Technology University, Pune. Today we are here to go through the experiment titled Verification of Cam Jump with different cams. Here the setup which is available for us for this experiment is in front of you. The specifications of this setup are going like this, where we have a camshaft made up of stainless steel, and we have different types of cams with us: tangent cam, eccentric cam and circular arc cam, which are made up of hardened alloy steel. With this we have followers, roller follower, knife edge follower, mushroom follower, which again are made up of hardened alloy steels. If you look at here in this tray at this side, we have different cams and different followers. Okay. One of the follower and one of the cam is already in this setup. Now these two cams are tangent cams, and we have on the follower side knife edge follower and mushroom follower. Okay. So other types of followers and cams are being utilized here in this experimental setup itself, where we can find this is roller follower in touch with eccentric cam. Okay. So on the cam shaft, the eccentric cam is already mounted, where the cam shaft has been connected through coupling to the motor. The capacity of the motor for this experimental setup is half HP. Okay. Now the rotation of the cam is measured with this tacho generator, which will measure and display us on this control panel, where we will able to see this control panel controls the motor speed with DC drive. So this is the control knob with which we can vary speed, and that the speed will be displayed on this panel. This is how the control panel is. Now if you go through the details of this experimental setup, what we find, we have cam and follower with the compression spring here, which will ensure the follower is always in contact with cam profile. Okay. Now on top of it, here you can find a platform made to keep different masses. So our experimental setup has these different masses: 100 gram, 200 gram, 300 gram, 100 gram, 200 gram, 300 gram and 500 gram. So these 4 different masses we are making use, and we are going to plot it on this platform. Okay. Now with this we can get ahead with concept of cam jump phenomena. So this is how the experimental setup is. Now for understanding cam jump phenomena, what we need? We learned it in theory that cam and follower is a mechanism, and it has got number of applications in different machines. But the requirement of any mechanism has to be, all links of the mechanism should be joined together always in all operating conditions, whereas there is no permanent joint between cam and follower. Okay. To ensure this, we need to make sure that the follower should always be in contact with cam profile surface. Okay. So this is what we are calling it as a mechanism. But in cam follower mechanism, we may face the one of the undesired condition, undesired situation, where the operating speed of the cam, if it goes beyond certain limit, then we may come across a situation where follower will lose its contact with the cam. That may happen. So from designer point of view, what we need to ensure, that follower is always in contact with cam in all its operating speeds. Now how are we going to perform this experiment, or how are we going to analyze this cam jump phenomena? For that we have different masses. For that we have DC drive, we will make use of this experimental setup, and we will observe if I change mass of the follower with these additional masses, if I change mass of the follower, how it is going to affect on cam jump speed. Now, this could be done in this fashion, that we go on keeping these masses separately on this platform, and we go for getting readings of cam jump speed. Now, how exactly it can be observed? We start our setup, slowly I go on increasing speed, okay, and you can observe for a moment where I have different speed for the cam, I get that follower is reciprocating and cam is rotating, that too both of them in contact with each other. That means what? Whatever desired follower motion we are expecting in the machine, we are getting it through this cam. Okay. Now, we keep on increasing this rotating speed with the control panel. What we find here, that we may find at one stage that follower will lose contact with the cam, in turn it will not follow desired motion as per the design of cam and follower mechanism, which is undesirous. So, we are interested in noting down at what speed the follower is going to lose its contact with the cam profile. Okay. That is the moment where we start getting cam jump, loosening of the follower from the cam. So, let us say if you have this tangent cam with us and this is the knife edge follower, if I have this situation, that is fine. If I have this kind of situation, definitely this follower will not obey or will not follow the motion as per design of the cam profile. So, we need to ensure that always this follower needs to be in contact. Okay. So, we will slowly increase the speed and we will catch the moment where exactly this cam jump, loosening of the follower is happening. Okay. So, that moment we will stop the increase of the speed with this DC drive, and we will note down at that particular mass, this is the jump speed at which jump is occurring, beyond which the cam and follower mechanism will not be a mechanism itself, isn't it? So, we need to ensure that for particular given pair of the cam and follower, we need to make sure that the operating speed of the cam is always below this limit, this jump speed. That is what we are verifying or learning cam jump phenomena with this experimental setup. Okay. Now, with understanding of experimental setup and theory behind the performance experiment, we can go for actually taking readings. Here what we will do, as we are going for verifying cam jump phenomena, at the end we are going for plotting a curve. On the graph paper, we will be plotting on x axis mass of the follower in kg, and on y axis we will plot jump speed in RPM. And from this curve we are going to verify jump phenomena or analyze jump phenomena in the cam and follower. For that case, in total we will have 4 readings, one without any mass on the follower, then we can have 200 gram, 300 gram and 500 grams put on this platform. So, we will get 4 points on the graph to draw a curve, and from then we can analyze that. Now, we will start with one case. I will just put 200 gram in platform. With this, I will fix it up with this nut, wherein it should not lose when we are taking jump speed. Now, what we need to observe and how are we going to decide that this is jump speed? Okay. Typically speaking, I will put this DC drive on, gradually go on increasing RPM of the cam, okay. And the moment when the follower is loosening contact with the cam profile, that moment I need to catch, and that will be, at that moment whatever speed on the display will be the jump speed, okay. Now this is the case, we started with 200 gram mass on the follower. Now you might have observed one thing, that in the explanation we were looking at the experimental setup from the front side. Now we have changed our angle of view, where you are able to view in this direction. The loosening of the follower from the cam is to be observed, and this loosening will be observed on this bright wall background, okay. So I will start gradually increasing the speed. I will take for that help of Mr. Mahesh. Mahesh sir, please start gradually increasing the speed, and you keep your eyes on the cam and follower, okay. If you check it out, exactly at what speed we get cam jump, loosening, what you can observe, when you are focusing on the contact between follower and cam, you will find a white line, the bright line, because of this wall reflection through this cam and follower to lens. So you will observe a white line, and that will be the jump speed, okay. I will just make sure I will visualize in the screen. So you can observe on the screen a bright horizontal line because of the wall reflection between cam and follower, okay. So we have, yes, this is the moment where we are able to see the white line, slight horizontal line between follower, roller follower and the eccentric cam. That is where the jump speed is. Now if you observe the speed on the control panel, what you find in that case, the speed happens to be 644 RPM. So for 200 gram of the mass, we put it on the platform here. The jump speed observed in that case is around 644 RPM approximately. So this is how we are going to take readings for the jump speed. Now we may get a little bit misunderstanding that we have to understand whatever jump speed we got it at 644 RPM, we will have this jump, this loosening or the gap between follower and cam for all readings beyond this 644. So we need to keep eye where exactly the jump is going to start. So we are interested in jump speed where the jump is going to start, that is cam jump phenomena, because beyond that we always find there is gap. Below that we will not find the gap between follower and cam, and the operating speed of the cam rotation should be always within jump speed, well below the jump speed. So when we want to keep this cam and follower in the operation, in the application, you just make sure that your operating speed is below 644 RPM. Yes, and that is how we are going to get the graph plotted. Okay, I will just reduce the speed and I will explain how exactly we are going to get graph. Now what you can observe, if I plot graph of jump speed on the y-axis and mass in kg on the x-axis, we will get 4 different points for 4 different masses. If I try to plot a curve, smooth curve between all these 4 points, we will get a negative slope curve. what it says? It says jump speed is getting down as we go on increasing mass. So, if I increase mass on x axis, we will get decrease in jump speed, and that is why we get negative slope curve. Now, this negative slope curve verifies with the theoretical equation. Now, what is that equation? That jump speed is inversely proportional to the mass of follower, and that is what we get it practically also. So, that is where we are verifying jump phenomenon in cam and follower mechanism, and we analyze that as we go on increase mass, we get reduction in jump speed. So, with this help, whatever application we are in, accordingly we can set the jump speed of particular cam and follower mechanism, and we will avoid occurring of jump in particular application to keeping this operating speed below, well below jump speed for that particular configuration. This is how we can analyze, or this is how the application of the performance which we had today. I hope this will be clear to you definitely, and if you have any doubts, definitely you can contact me at any time on my official mail ID, that is sateesh.patil@mituniversity.edu.in, that is satish.patil@mituniversity.edu.in. Thank you very much. Keep learning.